Correlation adjusts covariance, so the relationship between the two variables becomes easy and intuitive to interpret. Now, a correlation of 1, also known as perfect positive correlation, means the entire variability of the second variable is explained by the first variable. In our case, this means that for every additional square foot of size, we would expect an increase of, let's say, $1,000 in the house price. 5 additional square feet will lead to a price increase of $5,000. 10 additional square feet to a price increase of $10,000, and so on. The observations in our plot will form a straight line, as the correlation between size and price must be perfect. It would mean size is the only variable that determines a house's price, and we can easily calculate a house's price if we know its size. The correlation is deemed positive because when we add plus 1 additional square foot, the price goes up plus $1,000. It moves in the same direction. Okay, it is easy to understand that in real-life situations, we can rarely see a perfect correlation. It is much likelier to observe an imperfect correlation, such as the one we saw earlier. Yes, size is one of the most important variables that determine house prices, but it isn't the only one. Other factors, such as location and year of construction, are very important to buyers. So we can't expect that a house will be purely valued based on its size. And that's how it works with most things. Even company shares. There are several variables that determine share prices: industry growth, revenue growth, profitability, regulatory environment, growth perspectives. Tens of variables. The more similar the context in which two companies operate, the more correlation there will be between their share prices, as they will be influenced by the same or similar factors. It makes sense, doesn't it? A correlation of 0 between two variables means they are independent from each other. We would expect a correlation of 0 between the price of coffee in Brazil and the price of houses in London, right? The two variables have nothing in common. And finally, we can have a negative correlation coefficient. It can be a perfect negative correlation of -1, or much likelier, an imperfect negative correlation of a value between -1 and 0. Think of the following businesses: a company producing ice cream and a company selling umbrellas. Ice cream is sold more when the weather is very good, and people buy umbrellas when it's rainy. Obviously, there's a negative correlation between the two, so when one of the companies makes more money, the other won't. This is an example of a situation where the prices of two companies are influenced by the same variable, but the variable impacts their businesses in a different way. Okay, very good. This is how we can calculate a correlation coefficient manually. The truth is, though, no one does this nowadays. People use different software packages. In our next lesson, we'll learn how to calculate the covariance and the correlation between the prices of two companies, Procter & Gamble and Beiersdorf. It will be a lot easier and significantly faster as we will use Python. Thank you for watching.